Good morning, good morning, good morning. I hope everyone is happy and healthy and comfortable and confident. Fabulous. All right, so we are starting our Unit 7, which is radical functions. Now, I have used these rules that are in the properties of exponents, and I use the policy mad spasm. When we multiply coefficients, so we multiply coefficients and we add the exponents. We divide coefficients and subtract the exponents. And we raise a power to a power, we multiply the exponents. Now, the only thing that's at all tricky about this is when we throw in fractions or when the bases are different. So I want to talk about the parts of a power as well. So if I'm going to write down three different pieces. I've got 3x to the 5th. This is a standard power term. This is a standard monomial. This has a coefficient of 3. Because I can rewrite this as 3 times x to the 5th. That means that x is the base of the power, and that 5 is the exponent. Now, the reason why I wrote that very quickly was that there's a few things I can add in here. If I add a negative 3x to the 5th, this is actually the same thing as saying negative 1 times 3 times x to the 5th. Doesn't seem like it's all that big of a difference, but kind of keep that in mind. Or what happens if I write it with parentheses? So if I put 3x to the 5th with parentheses around it, this is saying that the 5 applies to the 3 as well as applying to the x. And so this is going to be 3 to the 5th times x to the 5th. Because in this blue case, the base is 3x, risen to a power of 5. Okay, so basic rules, properties of powers covered there. Now, the bases always have to be the same in order for any of these rules to apply. The bases must be the same. Now, you'll say, oh, that's easy. Okay. It's fine until we get to page 2. So, I'm multiplying. And I'm going to multiply the coefficients. There's a coefficient of 1 in front of this, so 4 times 1 is 4. And I add my exponents. My base stays the same, and I'm going to do 5/3 plus 3/2. Now, if you are not keen on fractions, please use your Desmos scientific calculator. 3/5 plus 3/2. And then keep it as a fraction. That is 19/6. So this is p to the 19/6. Okay, here we're multiplying, but here we're raising a power to a power. And when we raise a power to a power, what do we do to the exponents? We multiply them. So we have y, and then we've got 3/4 times 2/3. And when we multiply, we cross cancel, So the 3 cancels with the 3. 2 goes into 2 one time. 2 goes into 4 two times. This is 1/2. So this becomes y to the 1/2 times x to the 5/3. Now this is where you need to pay attention. It says the bases must be the same. So we have a base of y and we have a base of x. In that case, the bases are not the same. So we are done at this point. It is simplified as best as possible. Okay, so we're going to take care of what's on top first and then handle the bottom so we can keep the bottom the same. And we're multiplying those two powers. And as a reminder, when we multiply, we add. So we have 3 halves plus 1/2, which is 4 halves, which can be simplified down to 2. So we have a squared over a. Now we have to remember that because there is an a here, it is actually a to the first. You can do this a long way, which would be a times a over a. The a's cancel out, we are left with a. Or you could recognize that there's more a's on top, and so a is going to stay up top, and then you subtract the exponents, so 2 minus 1 equals 1, which is how we get a to the first power. Okay, so here it's applying to both. The exponent goes to both of the items. So we're going to do m to the 3 halves squared over m squared. Now raising a power to a power, we multiply. That gives us 3 halves times 2 over 1. Cross cancel, that gives us 3. That gives us m to the 3rd over m squared. And just like I did before, I can break them down. And I can recognize that there are more m's on the top, and 3 minus 2 is 1, so our final answer is m to the first power. So you should be able to simplify basic powers even if there's fractions. Now, if you remember correctly, well, no. Let's just, never mind. Okay, I'm going to break it down into its factors. So I know 4 goes into this because the last two digits are divisible by 4. So 4 goes into 11 twice, carry a 3, 28. And that's 4 times 7. And 4 can be broken down into 2 times 2. And 4 can be broken down into 2 times 2. Now, because there's an exponent of 4 right there, that tells me the number of slices of bread I need. So I've been using the analogy of how many slices of bread do you need to make a sandwich? Well, in square roots, you need 2 slices of bread to make a sandwich. Well, in this situation, we aren't going to have 2 slices of bread. We are going to need 4 slices of bread because the exponent is 4. So because this exponent is 4, I need 1, 2, 3, 4 factors to come out in order for one term of 2 to be in front. And then anything that's left over inside the radical would just be multiplied back together. So that's how we simplify them. Step one is we're going to factor them. And then we're going to remultiply. Okay. So 81 is 9 times 9, which gives us 3 and 3, 3 and 3. How many slices of bread do I need? How many 3s do I need? I need 1, 2, 3. That means I can take 3, 1 3 comes out. So that means I have 8 times, we have our 1 3 that comes out. And then this stays inside the radical with the cube root. 8 times 3 is 24. So this would be 24 cube root of 3. Okay, 96 is 12 times 8. That's 4 times 2 and 2 times 2. This is 3 times 4 and 2 times 2. How many 2s do I need? I need 5 of them. 1, 2, 3, 4, 5. That means 1 2 can come out. But what remains inside is going to be a 3. Now, if I expanded this into u to the 5th, you would see 5 u's. And if I need 5 in order for one of them to come out, so guess what? 1 u comes out, so it's going to be 2u, the 5th root of 3v to the 3rd. $80 is 8 times 10, 4 times 2, 5 times 2, 2 and 2. Okay, I need 4 of whatever I take out. 1, 2, 3, 4. That means a 2 can come out. If I've got 6 x's, and I take out 4 of them to bring 1x out, what do I have remaining inside? Well, it's just going to be an x squared. And another way to think about this is we just subtracted. We subtracted x to the 6th minus x to the 4th. Which is why it's x squared. We can do that same thing with the y to the 8th. We can recognize that y to the 8th minus y to the 4th is going to give us y to the 4th. Oh wait, but I can take out a second one. So I can take out 2 sets of 4. Technically, that's not. 1, 2, 3, 4, 5, 6, 7, 8. I'm taking out 1, 2, 3, 4, and I'm taking out 1, 2, 3, 4. That would become a y squared that goes on the outside, and nothing remains on the inside, because I took out 1 pair and 2 pairs. So our final answer would be 2, x to the 4th, y squared, and then the 4th root of x squared. Okay. What is most important about this is that the base must be the same. If the bases are not the same, you cannot combine radicals. So, the base here is the cube root of 6. This means I have -2 of something minus 1 of something. And -2 minus 1 is a -3, and then put your somethings left. So if you highlight it, it's your something, it's your variable, it's your placeholder. Okay. Freaking stuff. All right. Here, the first thing I said is that the bases must be the same. Well, the bases aren't the same here, so I have to break this one down. Why am I not breaking down the 4? Because I know 4 is 2 times 2, and that's not going to break down into anything. So this is 4 times 8, and this is 4 times 2, and I still don't have 3 of anything. Now I do. So I have 1, 2, 3 factors coming out. So that means a 2 comes out. This becomes -3 cube root of 4 plus 3 times 2 cube root of 4, because the 4 is still inside. 3 times 2 is 6, so we have a -3 cube root of 4 plus 6 cube root of 4. And so now we have to think, okay, I've got a -3 of something plus 6 of something. I have a -3 of something plus 6 of something. And they're the same somethings. So this becomes a +3, and then what is my something? Cube root of 4. Now, when you're adding and subtracting, the bases have to be the same. When you're multiplying, you can simply just group them together. And I'm going to break them down. That's 2 times 2. This is, oh, wait, actually, if I look at that, you should be like, wait, what'd you do? Okay. So in all the other times, we've broken them down all the way. But how many numbers, how many of these do I need in order to be done? I need 3. Well, look, I've got, here's 1 4, 2 4s, 3 4s. I don't even need to break them down. I can already take my 4 out, and this is equal to 4. Because there's nothing left inside. Okay. The bases have to be the same. You can't say you have 4 or you have 3 of something and then 5 of something else and try and put them together. So we're going to put them together first, simplify it. So we have 3 times 5 is 15. Then we have the 4th root of 24 times 2. (24) is 6 times 4, 3 times 2, 2 times 2. And again, I'm looking for 4 of something. 1, 2, 3, 4. I've got 4 of them on the inside. That means I can pull a 2 out. That is 15 times 2 times the 4th root of what's left inside is a 3. 15 times 2 is 30, and the 4th root of 3. 2 more examples. Okay. When you've got a radical on the bottom, the first thing you have to recognize is that we cannot leave a radical on the bottom. So we need to find a number that we can multiply, so turn this into a whole number. So we have to get rid of this radical completely. So 25 is 5 times 5. And I'm looking at this going, okay, well, how many do I need? I need 3 5s. But I don't have 3 5s. I've got 2 5s. So I need to add a cube root of 5 to my mix at the bottom in order to kind of clean up this mess. So that gives me 3 5s at the bottom. Now, whatever you do to the bottom, you always have to do to the top. This leaves me with a 5 at the bottom and a cube root of 25 at the top. Now, can I simplify the cube root of 25? No. So what I need to write yourself a note is no radicals in the denominator. Okay, so I have something in the denominator and I need 4 of them. So I'm going to break it down. I now have 2 of them. So I need 2 more. So I need a 4th root of 4. Now, that gives me 1, 2, 3, 4 2s. So a 2 can come out of the radical and come out into the real world. Now let's simplify the numerator. So we have to list our factors. And I'm looking for 4 of them. That means I can bring 1 2 out of the radical symbol. And oh wait, this 2 cross cancels with this 2, so really I just have nothing left. I'm bringing a 2 out of the radical. I still have a 4th root, and what do I have left inside the radical? But 1, and that's what it simplifies to. We're going to practice a lot more on this simplifying radicals. What I need you to remember how to do is, how do I change a fraction coefficient to a radical? So if you were to change, say, x to the 2/3 into a radical exponent, I need you to remember that the 2 becomes the exponent and the 3 becomes the radical. Always the numerator becomes the exponent and the 3 becomes the radical. So this is going to be, can be written 2 ways. It can either be written as the cube root of x squared, or it can be written as the cube root of x squared. Now, you don't have to have the parentheses. You could just do the cube root of x squared. So the only thing that's different is the location of the exponent, and honestly, that doesn't affect our answers here. So again, if I have y, actually 4y to the 2/5, the 2/5 doesn't apply to the 4. It just comes out front. The 2 becomes the exponent, the 5 becomes the radical. This is going to become the 5th root of y squared. Okay, if you have any questions, please feel free to send me an email, ask a question, reach out, and I hope you are all doing fabulous.